Today we're going to be looking at trigonometry, and we're going to be looking at the trig ratios. Now the trig ratios only come into play when we're dealing with a right angle triangle. Before we start looking at those ratios though, I just want to show you some of the Greek letters that we use when we're dealing with trig and labeling angles. So the most common one is theta, so that's the symbol for theta. Another one that's used often is alpha. And then a third one is beta. So those are the Greek letters, just that when you're reading questions and you see these symbols or these letters come up, you know what they're called. Okay, so now we're going to look at the actual right angle triangle. So if you remember, in a right angle triangle, and only in a right angle triangle, we have this special side called the hypotenuse. And the hypotenuse only exists in a right angle triangle. It will be the longest side, but it's defined as the side opposite your 90 degrees, because in a scalene triangle, you could also have the longest side, but it's not called the hypotenuse unless you are opposite your right angle. Now, there are two other sides to this triangle, and what we do is we actually label the sides based on the angle we're looking at. So if we were looking at theta, then this side is opposite theta, and this side is adjacent to theta. However, if we were looking up here at alpha, then now this side, which was opposite theta, is now the adjacent to alpha, and this side over here, which was adjacent to theta, is now opposite alpha. So our trig ratios, we're going to write out the definitions here. So sine, and we write it like this, but we don't call it sin, we say sine. So sine of theta is equal to opposite over hypotenuse. So I'm just going to take out alpha for now. And then we have cosine, which we shorten as cos. So cos of theta is adjacent over hypotenuse. And then we have tangent, which we short as tan. And tan of theta is opposite over adjacent. Now this does seem like a lot to remember, but there is a quick way for us to remember this, and that is SOHCAHTOA. So here is SOHCAHTOA. And so you can see we've got sine opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over adjacent. And if you just remember SOHCAHTOA, which is kind of a catchy little word, it's kind of easy for you to remember. Okay, so now we're going to look at, well, how do we actually use all of these trig ratios? So we're going to start here. And in this example, we're being asked to find various trig ratios. So the first one is asking for sine. So we're going to remember that sine is opposite over hypotenuse. And with respect to A, the opposite is 3. So if you look at where angle A is and you go across, so opposite is 3. And my hypotenuse is always across from your 90-degree angle. So my hypotenuse is 5. And with trig, we always just leave our ratios as fractions unless the question tells us to round to a decimal value. So you would leave this as such. Okay, so now they want cos of A. So remember, cos is adjacent over hypotenuse. So we look again at angle A and we want the adjacent. So there's the adjacent. It's the side that, it's the length that makes up the angle. So there's your 4. And then my hypotenuse is still what we had there as 5. So we have cos of A is going to be 4 over 5. Okay, now we're going to slide over here and look at this one. So now we're looking at B and we want tan of B. So if we remember SOHCAHTOA, so tan is opposite over adjacent. And if I look there at my angle B, the opposite to B is 4 and its adjacent is 3. So we have tan of B is 4 over 3. And remember, we're not going to work that out into a decimal. We also don't use mixed numbers. We keep it just like that as an improper fraction. So here we're still going to be looking at the example, and now they want us to determine the value of angle A to the nearest degree. Well, we could use either sine, because we have sine of A is 3 over 5, or we could use cosine because we have cos of A is 4 over 5. So what I'm going to do is I'm going to show you both ways. So if we use the sine option where we said sine of A is 3 over 5. Now you're going to need your calculator and you have to remember, so I'm going to put this for you as a reminder. Make sure your calculator is in degrees. And not in radians or gradians. Otherwise, you are going to get the wrong answer. So you want to make sure your calculator is in degrees. And if you're not sure how to do that, you can just Google the model number of your calculator and actually just type in, put in degrees, and you'll actually get to the page of your manual where it explains to you how to do that. And it's really simple. But yeah, that's what you're going to need to do. So now we have sine of A is 3 over 5. So something we have to remember is sine of A is not sine times A. Sine is a function. So it's sine of A. So what we do is your calculator has what's called the inverse function. And that usually would be over your sine key. So it'll be a second function of your sine key. And what you're going to do is you're just going to type in for your inverse sine. So you're going to look for that second function or shift button. And it's generally over the sine key. So you want inverse sine. So this term here, this means inverse sine. It doesn't mean sine to the -1 because remember, sine is not a number. Sine is a function. So the inverse of a function, we write it like that. But it's not an exponent, okay? So you're going to go inverse sine of 3 over 5. And that's going to give you the value that we want. So that's going to give you your A value. And remember, we want to go to the nearest degree. So let's inverse sine of 3 over 5. And we get 36.87, but we want nearest degree, so that becomes 37 degrees. And we are approximating, so we're going to put our approximate symbol up there, and that gives us 37 degrees. We could also have used our cosine definition because we also had cos of A. So we had cos of A is 4 over 5. So let's just give us some space here and work out what we will get for if we decide to use the cos of A. So we have cos of A is 4 over 5. So now, again, make sure you're in degrees, and you're going to use your inverse cos function. So that should be second function or shift and then your cos key, because if you look at your calculator, you'll see above the cos, you'll see your inverse cos. So if we do inverse cos of 4 over 5, we get the same answer. And we should, because if you're going to do things with the same question, so you're finding the same angle, okay, and you're doing it two ways, if both ways are correct, then you have to get the same answer, because you can't have the same angle and saying that one way it's one value and another trig ratio gives you a different value. Okay, so that's really important. So it doesn't matter which one you do. So if you were doing this for homework or in a test, you don't have to show me both ways. I just wanted to show it to you so you can see that you could do it either way. Okay, so here's our second example. So in this one, we want to find the length of xz. So xz, that's this length right here. So we want that length, okay? Now, we do have one angle. So what we need to do here is you need to work out, well, what do I have? So I have this angle of 32 degrees, and then I have this length of 5. The length of 5 is the opposite to my 32. Okay? And then I have xz. So sometimes students will rush and look at this and say, well, that's adjacent to your 32. But it isn't called the adjacent, because remember, xz is a special side. This is our hypotenuse, because it is opposite the 90 degree. Okay? So we have the angle, we have the opposite, and we want the hypotenuse. So we have to think about, in our SOHCAHTOA, which trig ratio uses opposite and hypotenuse. And well, that is our sine, because SOH, right? It's the SOH part of SOHCAHTOA. So that's going to be needing sine. So we're going to say sine, and we're not going to use a symbol because we know that it's the angle we're talking about is a value of 32, and it's equal to opposite, which I know is 5, over hypotenuse, which is what I was looking for. Okay, so we've already put in everything that we need. So now we're going to solve this like you would solve any equation. So we want to solve for xz. So what we're going to do is we're going to multiply the xz up, because remember it's being divided. So to get rid of division, we have to multiply. So xz sine 32 is equal to 5. And now it's this sine 32 that's being multiplied, so we need to then divide it. So we're going to go xz is equal to 5 all over sine of 32. And it's from this point now where you're just going to use your calculator. And it's going to give you the answer. So notice we didn't work out sine of 32 in the beginning, because we don't really want to now have a decimal value that we have to round. So we're going to keep it as sine 32. It's only right at the end that now we're going to use our calculators. And again, you got to make sure you're in degree mode and not in radians or gradians. And let's just round this. Let's say we're going to go correct to 2 decimal places. So once we do that in our calculators, we're going to get xz is equal to, and we have 9.435, which means that becomes 9.44. And remember, we are approximating, so we're going to put our approximate symbol up there, and that will give you the length of xz. With trig, we can also have word problems. And when we have word problems, the key is to draw a diagram. So you want to kind of take what they tell you and create your right angle triangle from this, okay? So when there isn't a diagram given, we are going to draw the diagram. That's really important because that's going to help us see the math of it all, okay? So a doctor is using a treadmill to assess the strength of a patient's heart. She sets the treadmill to an incline of 10 degrees. If the treadmill is 123 meters long, how high is the end of the treadmill raised? Okay, so let's put all of this into a diagram. So we have the treadmill being raised, and so that's going to be the 90-degree angle. We've raised it to an incline of 10 degrees, so we know that's 10. We know that the entire length of the treadmill is 123 meters, so that's that amount. And we want to know how high the end of the treadmill is raised. So I'm going to call this h for my height because that's what we're looking for, okay? And so from this diagram, I now have to do what I did earlier on here, where I had to figure out what am I looking for, what do I have, and what trig ratio does that translate to. So in our scenario, what am I looking for? I'm looking for height. So with respect to my angle, this is the opposite, right? And with respect to the triangle itself, this 123 meters, this is the hypotenuse. So which trig ratio uses opposite and hypotenuse? We're back at sine. So we're going to go sine of 10 is opposite, which is h, over hypotenuse, which is 123. Notice we don't put the units in here. We'll put them in our final answer. And then to get h by itself, I need to multiply by 123. So we're going to have the height is equal to 123 sine 10. And now is when you bring your calculator in. And it's going to give you your answer. And so we're going to go 123 sine 10. And that's going to give us, and let's also go 2 decimal places here. So we're going to go 21.36 meters. And remember, because we were given units in the question, we're going to give units in our answer. And also because this was a word problem, we are going to answer in words. So we're going to say, therefore, the treadmill is raised 21.36 meters. And that would give you the final answer. So before I let you go, I actually want to take you back up here to our trig ratios. And I want to just show you what we call the reciprocal ratios. So our reciprocal trig ratios. So if you remember, a reciprocal to a fraction is when I flip the fraction over. So if I have a over b, its reciprocal becomes b over A. And so the reciprocal functions to our trig functions are as such. So I'm going to put these in for you here. All right, so reciprocal of sine is actually called cosecant. So we're going to go cosecant of theta. So remember, I told you that it is, if we remember from fractions, where if we have a fraction a over b, its reciprocal is b over a. So in this case, sine is opposite over hypotenuse. So if I take the reciprocal, it becomes hypotenuse over opposite. Okay, and then if we have cosine, then cosine's reciprocal is actually called secant. And so we flip that around and that becomes hypotenuse over adjacent. And our last one is tan, and tan's reciprocal is cotangent. And that one, if we take the reciprocal, is adjacent over opposite. So notice that in your calculators, you don't have these functions. There's no cosecant and secant and cotangent. So we have to figure out, how do I write them in terms of sine if I had to solve for anything. So cosecant is 1 over sine. That's how we get a reciprocal of a fraction. We take 1 over. So secant is 1 over cos. And cotangent is 1 over tan. So that's how you would use your calculators to then determine what cosecant of something was. You would then go 1 over sine of whatever the angle is. However, if we were just looking at a right angle triangle and we needed cosecant or secant, then we would just go and take sine, and if you take the inverse of that or the reciprocal, it becomes hypotenuse over opposite. So just remember how we match those up. Okay, and that's it for today.